Hello guys, welcome to No Mystery Science channel. We're gonna start talking about our statics. So we're gonna start talking about vectors. Will be a quick review in a few videos. I'm gonna start with the example with how to add vector forces. First, determine the magnitude and direction of the resultant force in the figure below. So we're gonna start calling this force F1 and this other force F2 before we start. So I know my force F1 has an angle of 30 degrees with my horizontal axis, so we can start finding the components. So my F1x is equal F1 times cosine of 30 degrees in a positive direction. So my F1x is 100 pounds times cosine of 30. So my F1x is equal 86.6 pounds. Doing the same for my F1y, F1y is equal F1 times sine of 30. So my F1y is equal 100 times sine of 30. So my F1y is equal 50 pounds. So the vector form of our F1 is equal 86.6 I plus 50 J. Now we're gonna do this. So our F2x is equal minus, because I'm pointing to the left, minus F2 times sine of 60. Why sine? Because I have my vector here, F2x, and my other vector in y direction is F2y. So continuing, my F2x will be minus 200 times sine of 60. My F2x is equal minus 173.2 pounds. Now we're gonna do the same analysis for our Fy. So our F2y is equal F2 times cosine of 60. My F2 is equal 200 pounds times cosine of 60. So my F2y is equal 100 pounds. So my vector form of F2 in my vector form is equal minus 173.2 I plus 100 J. Now to find our resultant force, we can do our vector sum of F1 plus F2. Our resultant force will be F1 is 86.6 I plus 50 J plus minus 173.2 I plus 100 J. Don't forget that now we're gonna add I with I and then J with J. So our resultant force is equal 86.6 minus 173.2 I plus 50 plus 100 J. Our resultant force will be minus 86.6 I plus 150 J. So we know that our resultant force, I have a component in X pointing to the left, Rx, and a component Y pointing up, Ry. Now we're gonna do our resultant force. Here is our resultant. So we have the magnitude of my resultant square is equal minus 86.6 square plus 150 square. Now my magnitude of the resultant force is equal 173.2 pounds. And my direction, I'm gonna call here theta. The tangent of theta is equal Ry over Rx. So the tangent of theta is equal 1.73, and the arctangent of this, so my theta is equal 60 degrees. This is our first exercise. Now we're gonna move to the second exercise. Before we start, don't forget to like this video and comment what do you think about my explanation. Our second exercise is a little bit different. Determine the magnitude of force F and the resultant force in the figure below if the resultant force is directed along negative x-axis. So here I already told you that our resultant force, we're gonna point here. Here we're gonna be our resultant force. Now we're gonna start the same way we started the last exercise. We're gonna call here our vector P. So our Px will be minus, because now I'm pointing to the negative direction of my x-axis. So here will be minus P times cosine of 30. So my Px will be minus 100 times cosine of 30. So my Px will be minus 86.6 pounds. Doing the same analysis for my y direction, so my minus P times sine of 60. So Py is minus 100 times sine of 30. So Py is equal minus 50 pounds. Our vector form of P is equal minus 86.6 I minus 50 J in pounds. Here, since we don't know the magnitude of the force F, I'm gonna do here real quick. Our Fx is equal minus F times sine of 45, and my Fy is equal minus plus F times cosine of 45, the same of our last exercise. Here is my Fx, and here is our Fy. So knowing this, our vector form of F is equal minus F times sine of 45 I plus F times cosine of 45j. Now we're gonna do the same analysis. Our resultant force is this vector sum of F plus P. So our resultant force is equal minus F times sine of 45I plus F times cosine of 45J minus 86.6I minus 50J. Remember in the beginning of the exercise I told you our resultant force is along our negative x-axis. So I know the resultant force in the y direction has to be 0. So my components in y is F cosine of 45 and minus 50. So I know that F times cosine of 45 degrees minus 50 has to be 0 because of our question. So I know F times cosine of 45 is equal 50. So our magnitude of our force F is equal 70.70 pounds. So here is our first answer. Our second answer is find the magnitude of R. So we know that our Ry is equal 0. So we're gonna find our Rx. Our Rx is minus F times sine of 45 minus 86.6 I. We know that F times sine of 45 is the same as F times cosine of 45, because sine of 45 is the same as cosine of 45. So here is minus 50 minus 86.6. So our resultant magnitude of our Rx is minus 136.6 pounds. So we know that our magnitude of R is equal 137 pounds using just 3 figures. So this is our both answers. Thank you for watching till the end of this video. If you are not subscribed, please subscribe and share with your friends. Thank you. See you in the next video.